Hello, and welcome to the Team Reality Crushers technical video. This IronDev effort is a collaboration between SimBlocks.io, Walt Yates Associates, and Quantum Improvements Consulting. SimBlocks.io specializes in the integration of real-time 3D game engines for use in serious training systems by supporting industry standards for synthetic 3D terrains, communication interoperability, and immersive virtual and augmented reality experiences. We have previously participated in the STI One World Terrain Prototype OTA, where we developed a WGS84 compatible global terrain in Unity, and we have since continued our virtual world development in both the Unity and Unreal game engines. Our core product is the One World SDK for Unity, which expands the engine's geospatial world to visualize a whole Earth-based terrain with support for multiple levels of detail and the ability to place geolocated 3D entities and high-detailed content insets. Terrain data may be loaded from a local cache or streamed over the web at runtime from cloud services such as Microsoft Bing Maps, OpenStreetMap, or other custom web services. We have three main goals for IronDev. Build a distributed AR/VR platform to enable multiplayer cross-spectrum interaction. Leverage commercial gaming technology to produce compelling virtual experiences. And create several vignettes showcasing the capabilities of Unity and Unreal. With the adoption of commercial game engines in the field of live, virtual, and constructive modeling and simulation, some have suggested that we add gaming as a G to be LVCNG. But I would argue that the technologies used to build virtual and game-based products should be the same. There is no reason why they can't be the same. Why? Because we're not really talking about making games. We're simply using the latest real-time 3D technologies coming out of the commercial gaming industry rather than building our own engine. Why is this important? The advantage of building simulations this way is we are not completely reliant on government money to fund enhancements to the core engine. Basically, we can get many important new features and improvements for free. One of the main drivers of game engine adoption is the first-class support for virtual and augmented reality devices. These engines have tools to rapidly create scenes and deployment pipelines in place to create application runtimes that support a wide range of devices, from PCs to tablets to smartphones and immersive headsets.
Although the prices of these devices are low, the current cost to develop the virtual environments utilized by these technologies is high. Therefore, capabilities need to be developed to reduce these associated costs. The work we are showcasing for the IronDev Challenge does exactly this. We have focused on developing capabilities that can be implemented to top game engines as a way to reduce the time it takes to create virtual environments and assets, enhance the quality of data captured by interactions with the devices, and convey that information to trainees to improve training performance.
Technologies like these will enable our industry to move away from fixed hardware-based training systems to lighter footprint software-centric applications. But there must be an architecture in place to connect the various devices and data sources together. We are building our AR/VR platform on top of the Data Distribution Service networking middleware. DDS is the ideal choice for open architecture connectivity as it supports time-critical data interoperability, software portability, loose application coupling, and efficient distribution of data in a distributed system. Our first vignette includes several Unity scenes, showcasing the engine's ability to produce high-fidelity, ground-level environments with realistic grass, trees, and physical interaction. The Unity editor allows artists to easily create a variety of environments, including the desert landscape shown here. This swampland tile was generated in a matter of hours by one of our new artist interns. It features realistic water effects and a gloomy feel. We are collaborating with Serious Simulations, who has developed a wireless, full VR tactical maneuver simulator for dismounted soldiers. Combining synthetic terrain knowledge with weapon and shot tracking can facilitate after-action review benefits, such as bullet trajectory and line-of-sight analysis. Unity is also able to render building interiors. Unity Mars is a toolkit for mixed and augmented reality simulations that provides virtual object interaction within a physical space and may be useful for providing time-critical mission rehearsal information. Game engines are capable of visualizing multiple domains. Our second vignette shows a simulation of a surface-to-air missile launched from a rooftop in an urban environment towards an aircraft. The missile locks onto its target and destroys the aircraft. Next, a nearby drone is alerted and assigned to perform a reconnaissance mission. Earlier this year, SimBlocks was awarded a mega grant from Epic Games to support the CDB terrain format in the Unreal Engine. CDB is an open geospatial consortium standard to store virtual 3D representations of the Earth using spatially organized geocells, levels of detail, and layers. Our software provides the capability to either pre-process terrain content for intended modification in the Unreal Editor, and we also offer a pipeline to stream CDB content at runtime. In addition to reusing existing terrain content, SimBlocks.io is developing a building generation tool, which will be used to rapidly create dense urban environments containing detailed buildings with customizable floors, doors, windows, and materials. Unreal also supports realistic character animations. And we are developing embedded video and other sensor integrations. Our final vignette is an agent-based simulation experimenting with how the COVID-19 virus may be transferred over a period of time and space. The CRD model is used with color-coded susceptible, exposed, infectious, recovered, and deceased agents. Agents will become exposed if they come too close to an infectious agent. After a delay, an exposed agent will transition to infectious and pass the virus to other agents. In this experiment, an infectious agent will transition after some time to either recovered or deceased, with a 95% chance of recovery. SimBlocks.io strives to add value for our DoD and commercial customers, and we look forward to your feedback and questions.